Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is Bug Squashing Part 17, the 41st episode, streaming episode that is, that I've done, or that I am doing. So we're still working on these Mario Tennis bugs, although we're listening to the Waterworld music because it's just so good. Particularly last couple streams, we've been getting some hardware captures of some state registers and also some interrupt registers as the hardware will actually draw the contents of the screen. Where did I put those caps? I'm a little behind today. I ended up eating again late, but no worries. I just have to remember where I put these capture images. By the way, howdy guys in the chat. Skeleton, Daniel Collin, Dark Second, Row 2, Tommy Pyro ESP. Good to see you guys again. Skeleton seems tired. Hey Zokwar. By the way, Skeleton, you didn't miss too much. Just more hardware cap stuff. And particularly, I've been putting them together in this document here. Nope. And noticing when we were putting this stuff together that the hardware cap for the drawing status seemed really crappy. So I ended up adjusting the implementation of our little capture program here to make that not suck. And after that, started capturing some state from some other registers. Again, just to make sure that we were correct. The display status one seemed to look basically exactly the same. The interrupt pending one, however, looks a bit different, and I'm not entirely sure why that is at the moment. So yeah, was going to look into that. I was thinking for a sec, because I got a kind of a weird capture result. And ZZYXX, whatever you say that. Yeah, we're still working on the same bugs. Made some progress in terms of actually capturing what happens on the real hardware, but other than that, still basically working on the same stuff. Hey, Middle Voids. So yeah, that's what we're doing. Let me pull up the, I think these were from the same day, so these must be the latest caps. In particular, this is what I got from the display status last time. Really flickery, like more than I would have expected. A lot more variance. And I'm not entirely sure why that is yet. And I was going to try and have a think about that, but I need to kind of get my head in the zone here again. But yeah, we're still working on those same bugs. And I think it's going pretty well. This is what the, I believe the drawing status actually looked like once we got a better cap. And this basically matches, this is also with the top bit cut off, and there was some pretty good reasons why I did that. But it was basically in order to, like the top bit changed so much that it shifted all of our data, sort of expanded the data in order to get all the different changes in there in our little graph. So it expanded the data too much, and then you couldn't actually see what else was going on in the other bits. So this was actually enough information from that. And I think the other things I captured were from previous ones, looking at the dates here. Yeah, this is what that looked like in motion. So quite flickery, and you can see again the top bits sort of stretch out the data. And that's why I removed that from the capture. And then, yeah, this was the other video. And this is the one that concerned me. I'm not really sure why this had so much variance. So I want to, again, dig through this code to remind myself how it worked as well. And hopefully we'll get a stable capture of that this time. Or at least find out that if it's unstable, that's actually how it's supposed to be. And once we have that, we can actually start digging in and trying to make our emulator act a little more like this. And at that point, we should be looking pretty good. This is interesting, by the way, that Reality Boy is doing something strange. Also, I did want to look at this last cap here. What did this look like? It's here. Just pausing this video, there was a couple things where we the scanning was actually messing it up a bit. But these should actually look kind of ballpark the same if everything's working correctly. Sorry about the zoom on this. I'm just gonna kind of not care about that too much because it's a bit annoying to sort of move this stuff around. But I would have expected these to be a little bit closer to matching than they actually are. But it might actually be if every other frame that we're seeing ends up sort of changing the cap, and that's why it sort of changes as it scans like this. Maybe there's only a couple configurations about these bits, but it's just weird that it's not as stable as we would have expected, because we're using the same conditions to start and end the capture that we would in any other scenario. So I'm not really sure what's going on here, but we'll figure that out. In this case, though, yeah, this was the interrupt pending register that we're looking at here. Yeah. Yeah, so here we clear the interrupt pending. And actually, now that I think about it, though, I wonder if actually this would do it. Just that we're not clearing all the bits. That would be annoying if that fixed it. Interesting. When doing that, we actually get a little bit of more variance in mid-NAFN. That I did not expect. Let's see how Rush Boy does with this. Yeah, a little bit of variance there too, interestingly enough. I think that's kind of a good sign. I'm going to build this on hardware now. Or test this on hardware. Or sorry, I test this on hardware. We're just going to see if this helps. Somehow it wants to reinstall drivers. This is not fun. Yeah, it's going to be a lot of noises coming in, by the way, for USB stuff. Just bear with me here. Hey, Mad Moose. Okay, that seemed to do it. So yeah, just gonna dump this on here. Now again, even if we get like a really flickery output, my goal here is just to get something that's stable. And if this ends up helping, I want to again capture the other ones just to make sure that everything's stable. I think I made the mistake actually last time of only clearing the lower 8 bits of this register. Now that I'm looking at this code. Whereas this should actually clear all bits, which is what we want. And hopefully that will make this a bit more stable. Good timing, Skeleton. Hardware tests are a bit slow. By the way, I think I mentioned this earlier. I actually got a pretty good deal on a Virtual Boy and Mario Clash bundle through one of the Facebook groups that I'm on. So that means I'll have another Virtual Boy soon. That'll be number 4. And I need to rip one of these apart and get either some kind of digital output from them or just hack together some webcam thing. So that's still on my mind, and I have reminders for it, like weekly. But I think I'm going to wait till I get that fourth one, and then we'll see what I can do with the different hardware that I have. Because that would be a lot quicker when doing these kind of tests. But for now, we'll just wait. But it could make sense that this not clearing all the different bits could make the capture unstable. So that's why I'm sort of suggesting or suspecting this. And it also makes sense why I would have changed this to just the register feeding back into itself again. If I just had FF without the other byte, that would have made sense. Yeah, exactly, Studio C. How's it going? Nope, still jumping around. Red ROM. Still jumping around a bit more than I'd like. I don't like that. And somehow Reality Boy does not want to read this register. Really not sure why that is. It's also really interesting that both Rustro Boy and Manafin, whoops, wrong ROM, decided to get a little more unstable when making this change. It's a bit strange. Right, so we're going to clear all pending interrupts. We're going to read the interrupt pending value until we get game start and frame start set. Once we have that, we're going to clear pending interrupts again, and then we're going to start doing our captures. Let's actually do this too. That could do it. So we really need to make sure that these are cleared here. And the other thing that I might want to do here is I think I read the register here. But when it's this one, let's do reg value, just to make sure we're reading the same register here at the end of the capture. And now Manafin is blank, which probably means that something is not working properly here. Hey, Tsoding. So wonder why that is. Let's try with just writing this value back just to make sure it's only the bits that we captured. Oh, now I gotta clean my builder. So this is C. Not sure if you're kidding, but if you are, a good joke. If not, it's C. C is the new Rust. Let's see, where was that builder? There it is. So the reason I'm deleting my builder here is that every so often when building with this VBDE, it somehow creates these recursive build directories. And I'm not entirely sure why it's doing that. And every so often they get really long. They get too long. And then Windows can't actually use them anymore, and I have to clear the directories in order to continue building. Okay, so now we're getting more what I expected out of this. This is more stable. And the logic here makes sense to me, so I'm feeling good about that. And we're seeing more or less what I expect here. So I think we might have fixed this. And I think the logic here makes a lot of sense. Because we're pulling the pending register, and then we only clear the ones we read here. Additionally, up here, we make sure to clear all of them before we start doing our capture. I think I like this. I think I like this logic. So again, is reading 10 bits, which is as many as we need for interrupt pending. Yeah. Exactly, Druid 2. Actually, for interrupt pending, I think we're reading too many bits. Yeah, there actually should only be 8 bits for interrupt pending. Which this is actually correct, which means whatever we're getting at the end is going to be bogus. Bogus. Like a cap. Like a right pirate cap. Yeah, so we should only be seeing 8 bits here. And this is looking stable, so I'm liking this. So let's run this on the hardware. Yeah, sorry, Skeleton. I was referencing a joke that was made last week that just made me lose it. So. Mad Moose, I am actually really tempted to do that because I think it'd be a fun project. But it'd be a big project, and that's what keeps me away from it. A big project that no one would use. But if I ever want to do an LLVM backend for something, that would actually be a pretty cool thing to do. Because again, the VBDE stuff uses GCC VB, which is a fork of GCC, and binutils that actually supports V810. So all the parts in the pipeline after that are actually filled in. But that's the missing link, and plus the standard library, or at least enough of it to be useful. Also, in order to support some of the different data types, you would need like soft 64-bit floats. A couple other things. Same with 64-bit integers. So there's a lot of pieces there. But kind of something I'm interested in anyway, because I haven't done an LLVM backend yet. Oh, cool, Studio C. Chief Detector, I'm not even sure if I think it was actually funny, but I really liked it at the time. My sense of humor is not very advanced. Just ask anyone I work with. Okay, wow. So now we have a stable capture here that looks pretty much exactly like Rush Dual Boy. Let me check here. Okay, never mind. It doesn't look like Rush Dual Boy. It looked familiar. Okay, it actually looks like this. Looks exactly like this. That's why it looked familiar. You know, and come to think of it, this is actually interesting because additionally, I used to see some flickering stuff out here. Now I don't see any more of that, and I wonder if that's actually because because we're actually clearing all the bits now. So yeah. What that basically means to us is I'm going to leave this basically alone. And I'm going to update my stuff here just a sec. I'm looking at my little hardware test repo, and I had different branches for reading different registers. And I'm actually going to do this. Make this master, and then we'll do the other ones. Okay, I don't know. I don't know which one of these was more up to date, but if I do, I'll just update it here. So we want this. Yeah, we want not the updated upstream. We want the stash changes here. So we'll just resolve this by hand. Because we did make some functional improvements to this over time. This looks good to me. Let's run it just in case. Yeah, looking good. It's crying. Yeah, I know what you mean. That's something stashing and resetting and force pushing are things that I really shied away from for a very long time. So this looks good. And then on the other branches, I'm going to push this. And the other branches, I'm going to reset to this and then just uncomment stuff. And that's going to be good enough. In fact, actually, no, I do want to do that. And we should be behind, yeah, 1, 2 commits respectively. Good. That's what we expect there. This actually didn't change on disk now. If it actually looks at the contents. Yeah, there's certain things with Git now that, since I've embraced them, a lot of things have become nicer. But it took me a long time to really dive in and take advantage of those things. Okay, so here, we're going to grab the initial register value. So we're going to look at display status first. And here we need to make a couple changes because we need to do display status here. I don't think we need to reset these bits because we're not looking at that register. And then here we actually need to check this register here. I think that's what we do for drawing status. And then the last thing we do is this. And I know that 10's in here twice, but I actually want to have it that way to make sure all this stuff is sort of aligned with which register we're using. And that is basically exactly what I wanted to see here. That makes me happy. Yep, looking correct here, more or less. And Retro Boy should look a bit similar. Although we actually know this is wrong from the hardware, and I'm just going to run this on there now as well. I don't know what Emacs registers are. That's interesting, Mad Moose. I don't know if I used to do that or not, but I haven't done that in a long time at least. Just to make sure it recreates this, I'll run this again. So otherwise it doesn't update this padded file. And while this is happening, I'm going to just force push this to that branch. Oh, nice. That's cool, skeleton. So yeah, we don't need to update this. This looked good in the emulator at least. So we'll capture this again on hardware. I expect it to look the same. If it does, then we're looking really good. And then, oh, Chief Detector, is that Space Max? I think that's Space Max. And then we'll do the drawing status again, and this should not look like this. This should look like what we saw last time. Evil mode, no, that's the one, skeleton. You're absolutely right. I'm still using Emacs when I'm on the Mac. It's just a lot less often that I'm doing that. In some things, I'm still using Sublime there because like the assembler mode is a lot worse, I find, in Emacs than Sublime, or at least I haven't configured it properly, so it annoys me. Oh, I see, skeleton. Hey, look like some text. Beauty. That looked exactly like I would have expected, by the way. It looked exactly like this one, which is exactly what I wanted to see. And then we'll do the drawing status again. And before I do that, whoops, I forgot to commit this. Whoops, that was the wrong branch. That's fine, though. Because the contents were correct, so I can just reset to that branch. Force push. And then I will go back to the last branch. And here I can watch the other register. And we'll be fine. This can be based on the drawing one. It doesn't really matter the history here. I just want to keep the different versions of the source sort of backed up and available somewhere. That's really my prime concern there. I can always clean everything up later. Right now, I don't really care. Just want it to be preserved. So we should only need to change those things, and then I'll switch this comment here just again to make sure that everything's lined up and we know that this is correct. And I think that should do it. And here we go. Again, this is basically what this should look like, and this is again updated from what we had previously before I kind of revisited the capture thing. This looks how we expect. And in RushToolBoy, it also looks how we expect, which is great. So now if this looks like how we expect on the hardware, then I think we're actually done getting caps and we can start taking a look at them again, which I'm really looking forward to. Yeah, I can't really stand Emacs on Windows, to be honest. None of my key shortcuts are very natural there. Yeah, this stuff's pretty flickery. Sorry, guys. Force pushing's fine on branches, especially, but also on these repos where like no one's doing anything. I just force push because I don't care. Does not matter. Especially this little hardware test repo. Like the only reason it's even public is just because it can be. No one else is using this stuff. It's not even licensed. Oh yeah, I'm definitely always using Like on Mac, I'm using the Cocoa version of, I think it was Cocoa of Emacs. Which works really well, except you get the Mac scroll bars, which are light colored, and they just stick out like a sore thumb right in the middle of the Emacs window. But I like the editor, so. This sucked. This didn't look good. It looked like the old cap we had, which is quite annoying, actually. That's actually really frustrating. By the way, the reason I'm lifting my head up when looking in the Virtual Boy is not necessarily so you guys can see, because it's obviously you can't see anything, but it actually just hurts my back leaning over. That's kind of funny. So I don't really understand why this was so different now. Was this the only bit of logic I actually changed? We wouldn't need to clear the bits here. This should be fine. Something's weird here. It's especially weird because this ended up looking correct on the other emulators. Like, different than what we saw before, but what we expected. Even this. So I'm a bit weirded out by this, to be honest. Yeah, so this is the history we expected. I actually don't know how to look at the contents of a commit. Is it just git show this? Yeah, it is. Yeah, so all we did was change this one. And in particular, the logical improvements we had. Really not much here. I made the line a little bit smaller here, which made that clear. Different max entries. I changed some of the stuff for that. Oh yeah, I wasn't resetting pending interrupts before, which we need to be doing. Yeah, okay, so here even I wasn't clearing all the bits, which is a good thing that I updated that. Everything else was actually the same. Wait a minute. Yeah, that should be commented out. And I changed the drawing a little bit as well. It's a bit odd though, because it seems like here. Why would I get different values here? Is it because, no, because I'm capturing as well without this top bit, and that was the one that was changing all the time. I'm just gonna double check this. So this is the drawing status. And yeah, this top one is the one that just changes really, really fast. 15, 12, 11, 10, 9, 8. 4, 3, 2, 1. Yeah, so this is going to be correct. There's 10 of these. We definitely reset the registers here. Wait until this condition. Reset the registers here. So this is all looking good. Grab the initial value, mask off the top because we don't want this to change way too fast. Grab the latest value here and go until the interrupt pending register says we have a frame start. This should totally work. And especially it's concerning again that these are looking correct here. And if again, I don't mask this, we'll get something like this where it all gets stretched out and we get this other row because this wraps around, which again is what is expected. But why didn't this look like that on the hardware? I'm gonna just export one more time just to be sure. Make sure the padded ROM was updated by running an emulator, and it totally was. It'd be really nice to be able to just get hardware captures that I trust and actually be able to use them to do what we need to do. Yeah, something quite strange is going on here. And I'm wondering actually, this would be really weird. But I'm actually wondering if the hardware maybe doesn't clear some of these bits. Unless we actually write the right value back, which would be really weird because there's these race conditions. Because like, if we read, for example, the register value, in particular the register pending value, that could change before we actually write it back to clear. So even if we have this statement, whoops, what F12? There it is. So even if we have this statement, there's a race condition here between when we read this and then write it here that the value could actually change. So I don't think the value here should be dependent on anything. If we just write all the bits to 1, that should clear these. Yeah, I can check those again. They should be the right ones. This is the right one. This is correct. This is correct. And they have the right masks on them. And this is correct as well. So they should match. It could still be something wrong with the code, but I'd be surprised because we did look over that like 2 weeks in a row. This is going over the code again. Somehow, though, this was weird. I'm going to try this again, though. Just to see if there's any difference. So these should all look the same. They do. Then, and I'll check this on the hardware again. Which one do you mean, Dinner Colin? Do you mean the size of the array for the entries? Because I'm pretty sure I use num entries and compare that with the end. Here, max entries. I guess the only reason I could actually miss that is if this was not as big as I told it to be. I'm not actually doing any pointer compares, if that's what you mean. I mean, I could do an earlier commit, but again, all I'm seeing is these are the only changes. But yeah, I'm going to try it with just writing back these values here to see if we actually get something interesting. Oh, that's what you mean for the bit indices. Yeah, I should actually use that one. I need to do size of over divided by the data type, don't I? Oh, okay, yeah, that's what you mean. Yeah, we'll do that. Type it myself just because I want to. I'm used to Sublime closing all my parens. That's bad. I like doing it over size of 0 here, which is nice. I think I have some extra parens here. No, this should work. Yeah, I like this. I do also, by the way, have these extra parens on the outside because you should be doing that in macros, but I'm sure you guys are aware of that. So then we can do this. And I'll actually fix this before I upload it to the hardware or test this. Rebuild this. Got to clean my builder again. Yeah, looking good here. Looking good here. Ugh. Getting really annoyed with this. Looking good here. And now we'll test on hardware. Thanks for it too. Thanks, Corian. 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 Don't know how to say that still. Exactly, skeleton. But no, I won't give up. That's not going to be a problem. Yeah, it's pretty annoying. However, if we can get some stable captures of this register, then I think actually at least matching our hardware to that would really help. Fair, Mad Moose. And I mean, even if I match the hardware to the captures we get here, that actually only measures particularly the time it took to draw this exact content. So we would actually need a lot more testing cycles in order to figure out like how, if we adjust the size of the windows, how does that affect the size? Because it's non-deterministic how long drawing takes, or well, it's deterministic, but it's not constant. It depends on what you actually draw. So we'd need a lot of testing to get it like perfect. But I feel like if we just get this to match what the hardware does in this case, then it's going to be good enough for all the games. Okay, this I don't like. Let me explain in a sec here. Okay, so the main thing we did, change which register we're looking at. So we did the size of array thing so that would clean up the code down here. We switched which register we're looking at, and then here's the thing that I'm annoyed about. Yeah, Drew, too. I can't get much farther without changing the encoding scheme there. But here, this is what bugs me. It seems like this doesn't clear the interrupts like I expect, just writing all the bits. But this does seem to work. However, when I did this, when actually looking at the interrupt pending register, that didn't seem to work very well when it would actually look for start and end the loop. And I think that's why we got all those jitters. Because now this looks exactly like we expect in the hardware, and it looks a lot like Rustio Boy. Come on. It basically looks almost exactly like this. So that kind of bugs me. just so I'm sure that was the only thing I really changed here, I'm just going to do this again. And it's also interesting that basically all the emulators are treating this how we expect. Basically, the semantics of this register is that you have these different interrupt registers. One of them will tell you whether or not interrupt is pending. Another one will enable the different interrupts, and then one of them will clear the interrupts. And the way you clear them is that like each one of these interrupts has the same bit indices for the different interrupts. And it would seem that if you just write back, ones to any of these bits, it will clear the pending state for that particular bit. And so that's actually what I'm thinking, Daniel Collin, is that maybe we need to be careful that we only write the bits that are not used here, because maybe there's some weird thing with these other bits where if we write those, something weird happens. Frankly, I have no idea. But it did seem like when I had to do this in order to get the interrupt pending register to capture correctly, yet I had to do this to get any other register to capture correctly. One thing I could try, though, is just to write only the bits that we care about. So that's 15, 14, 13, which is going to be... I'm actually going to do this in the calculator just to make sure I don't miss anything. So we're just going to write them in this order. So we have 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And that's 16 bits, E01F. And that looks right because E is going to have the top 3 And then 0 and 1 is going to be a bunch of bits clear, and then 1F is going to be all these lower ones. So I think this is correct. I don't want to read the current value and then write it back. And the reason why I don't want to do that is because particularly here, it seemed like just reading this value and writing it back when we were looking at the interrupt pending register seemed to give us bad captures. So I don't want to read the value and then OR it and then send it back. Because again, there's also those race conditions. I'd rather, if we're able to, set all the ones that we can. So this is going to be easier 1F in that case, I think. And the only caveat with that is this case, which is when we're looking at the interrupt clear register. I do actually want to write the value that we read. And I also want to make sure we're using the value we read here when we're doing that. And that's, again, to make sure that we're the same value that we capture is exactly the one that we're clearing and the one that we're checking down here. But that's kind of a special case. I think this is more or less what we describe that we want. So if that's the case, then this will still look the same in the other emulators, which it does here. Yeah, exactly. That's what I'm thinking, at least. This looks the same. Rush to a Boy should look the same. And then hopefully this works on hardware. If not, there may be something to those other bits. I mean, for all we know, they could even be some weird debug stuff. The only things that I've seen games do, by the way, is they write back the exact value they read. But we can't do that in this case because we need to be sure that certain bits get cleared. Because we're actually like looking for changes in those registers. We need to not miss any. So our use case is kind of weird. But as I've been saying, when we get some good captures, implementing our hardware so it matches this, I don't think will be very difficult. It won't be trivial because I have to move around a bunch of stuff. But it shouldn't be terribly difficult. And I actually expect that to fix a lot of the issues that we have currently. And if that doesn't, then it's going to be really annoying. But at least we would know that that's a place that we shouldn't look further. But yeah. But this writing all these bits should be consistent with what we want. Pyro, I could disable them and then enable them again, but I don't want to do that because then I might miss one. Yeah, Chief Detector, what Daniel Collins said. Also, the EverDrive is nice. But I think there's some custom firmware now, or maybe it's the official firmware that's just been updated for the SD to SNES that allows you to write over USB. That'd be nice. I recently discovered actually at Datastorm that the 1541 U2, which is the cart that I have for C64, actually supports network devices. It has a USB port, and it'll do network devices with that, which is really cool because then you can basically treat it as an FTP server. So you can have it all hooked up, and while the C64 is running, you can FTP onto the SD card and then hit a couple buttons on the cart and have it load that into memory, which is really cool. And something like that for like Virtual Boy would be amazing as well. This didn't work. I could do inline assembly, but I don't think we need to. I don't think that'll fix our problem here, though. I think... So it seems like this is the only safe thing we can do, is write back the actual value. I'm still really weirded out by that, though. But I don't think this is a speed problem. I mean, this should basically just read the value into a register and write it. Maybe it'll do some indirection stuff for actually getting this register value, but I would doubt that. That's pretty cool, Daniel Collin. Also, I notice here, we're getting the register value and then doing this, but we actually should sort of differentiate this like this. That shouldn't make a difference. This should basically be the same loop. Of course, here we can rewrite it like this instead, which is a bit nicer. I like to do that when we do infinite loops like this, just to make it more clear. I don't think that'll fix anything, but that'll just clarify that to me. But yeah, it seems like this is the only safe option here. And that's a bit concerning. I wonder if there's something weird like writing back unrelated bits would change some internal state or something that would cause one of the interrupts to fire again. So for example, if it wouldn't clear one of these properly, then maybe they would fire immediately after this. Really not sure. But I think actually, I think this is the logic we want anyway. Or at least just clearing these bits. But I think this is basically what we want anyway. Ah, that's actually why I had this set up. By the way. I think this is why I had it like that. So this way we want to clear all the bits, or at least attempt to. And then we wait for the interrupt pending register to have game start and game frame set. And at that point, we're going to write that back to here, which should at least include these bits. Perhaps others, but that would give us a clean slate every time, and then we'd be able to watch this. Let's see if this works. Are you sure, Drew, too? Ah, I think you're right, actually. And that's a good catch. I think you're right, because we'll get register value and one of these. And if either of those would be set, then this would break. I think you're right. But I don't think equals equals is correct either. Unless we do this and these bits is equal to this thing here. I think it's going to be... And maybe that's what you meant. I think it has to be this. That's a good catch, by the way. I think this makes sense. And then actually, let's try that with this. And then we'll do it this way. We'll do this. There we go. That would make a lot of sense, actually, because I think that the values that I was seeing, and if we look at basically this, if this had just changed state immediately, then we only would have gotten like 2 register values, and then we would see the same thing the entire time, which looks like what I was seeing. Okay, that's a nice catch. And then here, I don't think it's a problem because we only look at frame start, and then this is the correct way to do that. Nice. Okay, so let's try this, because then this should work, I would expect. Okay, we get nothing in Reality Boy. That's a bit odd. Nothing here either. So maybe... Oh, whoops. There. That would do it. Okay. Yeah, because that way this wasn't set, except it probably, yeah, that would have been undefined. So this makes sense now. So yeah, so it worked in Reality Boy. Worked in Manafin. That's a nice catch. Works in Rustral Boy. And now we try hardware. But this I would feel good about. Let me do this again just to be sure. Because if this sort of fixes our problems, then that'll make me feel a lot better about this, about all the data we're capturing. And then we got to capture the other registers again, but that's fine. That's totally fine. This would be thrilling, but I had a beer before I started streaming, so I'm just kind of like, chill. I'm like apathetic with a hint of annoyed. But I think this would make sense if this worked. Exactly, Dura 2. Wouldn't take much. Yeah, exactly, Daniel Collin. But yeah, this could definitely explain it. If the game start and the frame start happen slightly one after another, that would totally explain what we saw here. Or could at least. Yeah, I could play with the camera zoom. Keeping that one in the back pocket for now. Do it when you guys least expect it. That works. Oh. Yeah, nice catch, Drew, too. And that makes more sense because, yeah, Stream 5. That makes sense too because we should be able to set these bits it doesn't care about. I mean, I think it's still good intuition to not do those if that was going to be a problem, but I think it would be a little odd. Okay, so first thing I'm going to do, we're going to update the history here. I'm going to do some git magic here to basically skip over this commit here. By interactive rebasing on top of the first one before these. And now we can commit this first one and squash the second. And that should do what we want. Good. So now we just get the logical improvements and then drawing status on top of that. Sweet. Force push that to that branch. And then we're going to try the other registers again just to make sure our captures are what we expect. And we're going to do the same thing where we reset to this one. And then just change the register to the one we want to look at. Wait a minute. Whoops. Hard reset to that. Now we should get the updated stuff. Good. A worst Git class ever with me not explaining anything. But that is a nice trick to just do a crap commit and then rebase and squash. Like that. But yeah, now we're looking at the drawing status, which should just be a matter of these couple things. So we change the bits we're looking at, and then we change the registers that we look at. And again, I'm going to test in all the emulators because I'm going to be damn sure this is working how we expect. It's really interesting, by the way, that Reality Boy is the closest to the hardware. Closer than the other emulators. Did not expect that. It's also one of the older emulators. But it doesn't seem to be one of the more popular ones, which is what's interesting. Like libretro and stuff use mednafen, which is really interesting. Number 2. Really going for that lame joke. Which I like, by the way. But I'm going to feel pretty satisfied if we can get good caps here at least. Because from there, making our thing match is not going to be the hardest thing in the world, I think. Particularly because like we have the outputs here now. And I can literally just like isolate these registers, which basically represent the state changes in the emulator, and be able to look at those. Now there was that difference in the drawing status that the Y position match thing would actually fire quite a bit, and we intentionally masked that out of the cap. So that is also something I'll want to implement at some point. But I don't think that'll fix the bugs we're looking at. So I'd like to kind of hold off on that. Have you tried that in Hegon, Chief Detector? I do have kind of a sneaky goal in mind, by the way, for Rustro Boy to make it the a primary lib retro core, but it's a ways in the future. That works. So we're gonna push this. Yeah, sorry if that was unclear. Manafin has many, many different emulator cores, and one of them is Super Nintendo. So that's why that made sense. So now we're going to do interrupt pending. And this one has a couple additional changes. Because we're going to change the one we're watching, and then we need to reset the bits here. And then we're also going to need to do this just to make sure we're getting the right stuff. And if all that's correct, which it should be, we should get some consistent values here. And we do. And we should get something that's consistent on the hardware that's not completely wrong. But I am still overall pretty satisfied with this approach. The code we ended up with here is still pretty straightforward. And we vetted it enough times now, I think, that I would call this fairly reliable. Given this capture works. But I think the logic here is pretty okay by now. And if this does get us decent captures, then this was a worthwhile approach for sure. By the way, guys, Daru 2 has his own emulator stream. Where he makes a Vectrex emulator. So if you guys want to see him fix some more code, see very small logic errors in other code, go ahead and check out his channel. No worries. It's a no-brainer to plug other emulator streams. Oh, sick. Oh, it works, guys. That feels good. Mad Moose. Oh, believe me, Drew, too, when we fix this bug, I will definitely swear as well. I'm calling it. So, before I take pictures, because that was a slow process, I'm just going to confirm basically matches this. I think it does. Yeah, it does. We don't need other pictures of that. So the last thing was the drawing status capture, and I think I just got a picture of that in the folder here. It's one of these. Yeah, it's definitely that one. I think I got a picture of it. Yeah, this is good. So we'll go ahead and nab this. This is going to be accurate enough for this. I think you can drink alcohol on the stream. Not when it's a driving stream. See you, Skeleton. Thanks for hanging out. Okay, so I actually just had it as a background layer here, which is fine as long as we can just move this around, which was on top here. Great. So this should basically do it. The drawing at Y position, and I'll add a note here as well for this drawing at Y position that's actually wrong. Good enough. And so now, yeah, so the current Y position counts up like we would have expected it to. Drawing exceeds frame period works like we expect it to. Writing to frame buffer 0 and 1 also basically work like we expect it to. Now, I was hoping to kind of see a correlation between these, but if you basically look at these ones here, remember that the way that I draw this is I always make sure that all the changes at least get one sort of character position to be visible. So it's very possible that actually this is stretched out a little bit. So I wouldn't be too surprised if, where's my line tool? Here. If this was actually a correlation. You see where I'm getting that from? Let's bring this to the top here. Oh, I actually did these as rectangles. That's kind of funny. Why is this not working properly? I don't know. Give me that color. Let's do it that way. What the heck? Okay, you know what? We're going to do it this way. This will be cheeky, but it'll work. Yeah. Something like this. I actually expect that this might be a correlation. That makes sense, right? Because if this were kind of stretched out longer than it would have been, then this writing stuff may have finished like halfway through the frame. In fact, this may have even gone really quickly if we had to capture all these. So this may even be like a quarter of the frame here. And in fact, the actual thing that we want to see, now that I think about it, is here, because we want drawing finished here to match here, the drawing stuff at the end here. So it's actually this is so dumb. this is the correlation we actually want to see. But again, I think this could make sense. There is some interesting stuff about this, though. Yeah, right here, Illuminati confirmed. I'm basically thinking it's a bit odd that the drawing happens really quite quickly, but the display stuff here for the left frame buffer actually happens at the same time, it looks like. That's a bit unexpected to me. But again, if this were really stretched out like this, in fact, I'm kind of tempted to do this without looking at the current Y positions just to see where this ends up happening. In fact, why don't I do that really quick? Let me go ahead and push this again. We'll do we'll just set up a new branch for the inner pending thing so we don't lose that. Could just use master, but that's fine. And then, yeah, it was the drawing status again, so we can just check out that branch. And then here, that should have reloaded. Oh, there it goes. I want to mask off those bits as well. And let's see which ones those were. Yeah, drawing status 12, 11, 10, 9, 8. 10, 11, 12. It's going to be E something. Yeah, so this was the top bit here. Basically, none of these are used except 0, 1, 2, 3, and 4. So if we do something like this, that should actually do it. In fact, we don't even need 0, but 0, 1, 2, 3, and 4 are the ones we care about in this case. Let's just try that. Something looks like this. Maybe that makes sense. I'm not sure yet. This is a little more confined to the left there, which is kind of what I expect. This one actually goes halfway through the frame, which is a bit more than I would have expected. And then we'll test that on hardware. Which I'm a lot more confident about now that we had captures that actually made sense. Nice or two. No worries. I didn't know I had that kind of influence. That makes us both feel good. cool. You guys. Blush. The dumbest thing. Yeah, I guess that could have been embarrassing at work. Thanks, Known. Nguyen. Okay, this is beautiful. So here's what's actually really cool. I was totally right. Looking at the capture, so when we mask out all these bits, what we get is these two bits flickering, and they end right here, like a quarter of the way through the frame, which is exactly what we would have expected. I'm actually going to add a note for that, because that makes me really happy to see. And then I feel really good about the things that we see here. It's still a bit odd that it's... Oh, never mind. I was totally thinking it would be weird that it's going to draw into a frame buffer that's displaying from because these timings overlap, but it totally doesn't, because we have frame buffer 0 and frame buffer 1, the different sets, and it's going to be displaying at a one set while it writes to the other one, and that's what the 0 and 1 writing thing here is. So that totally makes sense. Okay, good. This is all lining up, and I'm super happy about that. So finally, this is all paying off. Just going to write it like this. So lining it more to the left here. Shouldn't be that weird. I mean, it's comparing images. I'm just doing it in Photoshop because that's the tool that I have. I mean, it makes sense. But yeah, this totally works. Okay, I actually feel really good about this data now. Yeah, setting background color is still doing that, coding old school stuff. Yeah, no worries, Origami Bulldozer. No worries. All right, but now we finally got some good data. All this stuff is actually making sense. Just gonna move this rectangle a little bit. We totally see correlations between the different bits like we expected. There was a little bit of jitter because some of these actually do come from hardware, which again is what we expected. It looks like it's going to be drawing into the frame buffers that it's not displaying out of. And other than scheduling, it looks like we basically match in terms of what our emulator's doing. Except notice that this actually lasts too long. This should actually be like a quarter of the frame. fact, I'm going to go back here. And yeah, we changed those masks. Hold up. Yeah, so now this is what we would have expected here. Notice how some of this agrees with our emulator, some of it doesn't. Some of it agrees with the hardware, even in Reality Boy, not all of that stuff matches up. Yeah. So this is what we expect to see here. And then if we look at the other branches here, yeah, that more or less matches the hardware in Reality Boy. Definitely is different in ours. Interestingly enough, we get the right flickering here, but they happen at the wrong times. And then we'll do the interrupt depending one. Take a look at that really quick. Oh, hey, truck. Yeah, and so then here, this is kind of all over the place compared to this, but makes sense with some of the other state transitions that we had. So yeah, I mean, this looks really good. You can see basically, even looking at these, all the right bits do fire in sort of the right order, just at the wrong times. So I actually think sort of making these timings match what we see in the hardware is going to do us wonders here. So I think this was really good. But yeah, I think we're good here. And I think it's like 9:40 already, so I think I'm gonna cut this off. And next week, since we have all this good data and we know this is correct, I think that'll be a great time to actually start manipulating our timing code and making it match the captures we have here. So I think that'll be next week. But yeah, I think this was good stuff. I feel a lot better about our data now than I did before we started this. So it took a couple weeks to get this right, but I think that's okay. But yeah, this has been really fun. Thanks, guys. Appreciate it. Yeah, this will be really cool when we get this fixed. All right. Well, I'm going to go. Thanks, guys. All right. Yeah, thanks again, guys, and I'll see you next time.